For example, suppose you were interested in putting together an interactive text editor, such as a VI style editor, where each time the user presses a key, something happens. The cursor moves, the character that you pressed is inserted, perhaps nothing happens. Well, what you can do is define a whole bunch of functions for the actions that should take place in response to various key presses. For example, in VI, if you're in insert mode, then most of the keys that you press are simply inserted into the file. So we could define for ourselves a self-insert function that takes the current character that the user pressed as its argument and perhaps returns some kind of integer status information that can be evaluated to determine whether that character was successfully inserted. On the other hand, in what's called command mode, most of the keys the user presses on the keyboard get interpreted as commands of some kind. For example, if the user presses Control-B in VI, that means to page backward by a full screen of information. Or if the user presses Control-D, that means to scroll downward by half a screen. Certain characters, such as Control-A, don't have any default meaning, so we can define ourselves a no-op function that literally means to do nothing in response to keys such as Control-A being pressed. If you've ever used VI or observed someone using VI, you may know that if the user presses colon, that puts the editor into a temporary line editing mode where the remainder of the keys that the user presses up to the enter key are interpreted as some kind of line-oriented command, such as a substitution command. Okay, we've been careful to define all of these functions to have the same interface. That is, all of these functions take a char as an argument and return an int as a result. And so now we can create for ourselves something called a key map, which maps each character in the ASCII character set into some action to be performed. Well, in the ASCII character set, there are 128 keys, so we'll set up our key map as an array of 128, pointers to functions that take a char and return int. And then we can simply initialize this array of 128 function pointers. Now, the VI editor has two primary modes of operation. In command mode, each key the user presses causes some command to occur, whereas in insert mode, which I show on slide 8, most of the keys on the keyboard are simply inserted into the file being edited. All right, so let's take a look at command mode first. You may never have used VI, but that's okay. Control @ is the null character. And on many keyboards, Control @ is actually just ignored, but we will associate Control @ with no-op. So if the user presses Control @ and it does actually generate a null character, nothing happens. Likewise, if the user presses Control-A, which will actually generate a Control-A character, the standard thing in VI for command mode is to do nothing. Control-B, as I mentioned, pages back. Control-C, as you may know or might expect, will interrupt whatever the editor is currently doing. Control-D scrolls down. Colon causes temporary line edit mode to be entered. Little I, causes the editor to switch from command mode into insert mode. So in this case, that will cause the editor to switch from using the command key map to using the insert key map shown here on slide 8. Okay, so in slide 8, again, Control @ and Control-A do nothing. To leave insert mode and get back to command mode, in the VI editor you press the escape key. So for the escape key, we'll have a function switch to command mode that switches us back to using the command key map. And then for almost all of the regular printing characters, the space character, the exclamation mark character, the capital letters, the lowercase letters, etc., we're going to call this self-insert function, which will simply cause the current character to be inserted into the file. Now, notice that by using these keymaps, the behaviors associated with the various keys are not constant. That is, the user could reconfigure these keymaps on the fly to associate different commands with different keys. For example, the user might define Control-A to do some action, and we can change the function associated with Control-A from no-op to some other function on the fly while the program is running. Another nice thing about these keymaps is that the so-called driver loop, top-level loop that's causing the editor to run, is absolutely trivial. We have two different possible modes, command mode and insert mode, and we're going to start out with our mode being command mode initially. That's the standard thing in VI. And then we simply have a loop in which we obtain the next character that the user types, do a switch to determine which mode we're currently in. If we're in command mode, we're going to use the command keymap. If we're in insert mode, we're going to use the insert keymap. And notice how the keymap is used. We use the character that the user typed as the subscript into the keymap to identify the function that's supposed to be called. And we then call a function using the function call operator, providing the character that the user pressed as the argument to that function. Okay, so we use the character the user pressed both to look up which function is associated with that key and then as the argument passed into that key. So for example, that a function like self-insert will know what key was pressed and will be able to insert the correct character into the file. And that's it. So now we have a full-fledged user-modifiable text editor. Obviously we've left out a certain amount of detail, but this is the core of the thing. Next we're going to take a look at the typedef keyword that allows you to define a simpler name or more compact name for some complicated data type description. Typedef is also used to define system or compiler dependent data types so that you can have a single data type name that you can use in your source code, but that will behave in slightly different appropriate ways depending on what system or what compiler you're using. Alright, so here on slide 11 we have a variable named pi, which is a pointer to int. Let's suppose that we are too lazy to type int space star all the time for our pointer to int variables, and we would rather have a simple name that we can use instead of the int space star notation. Well, if you write down what looks like a variable declaration, giving the name that you want to use as the variable name, so in this case I want to use pointInt instead of int space star. So I write down int space star pointInt, and then I simply stick the word typedef in front. What had been a variable is now a data type name. Okay, so later in my code, if I say pointInt pk, that says that pk is a pointInt, and a pointInt in turn is a pointer to int. All right, so pk here at the bottom of slide 11 is a pointInt, which is a pointer to int. pj above it, above pk, is also a pointer to int. So a typedef is not a new type. It's simply an alternate name for some data type description. And this example of using pointInt instead of int space star is intentionally trivial. Here on slide 12 is a somewhat more realistic use of typedef. We just looked at the idea of function pointers. At the top of slide 12, we're defining pf as a variable whose data type is pointer to function that takes char as its argument and returns int. If we're going to have a lot of pointers to these kinds of functions, it might be nice for us to have a simpler name to use instead of that complicated syntax.